Hello, let's continue our Sudoku adventure with Killer Hidden Arrow Sudoku by Clover. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these cages in the grid. Digits can't repeat in a cage. So normally in Sudoku, I could put a 2 here and a 2 here, but you'll see that shows up red in this puzzle. Normally I could do that, right? But within the cage, I'm not allowed to. Just can't repeat digits within the same cage. In addition to that, there is a clue in the top left corner of the cage, and that tells us the sum of all the digits in the cage. So I could, for example, do, for 10, I could do 2, 3, 5. And that adds to 10. Obviously, I could do it in some other order as well. Still adds to 10. And I could use other digits to add to 10. All right. And then finally, there's a hidden arrow in every cage. So the way to think about this is at one end of the cage, either this end or this end, you can see they're all symmetric, so just not the middle one. At one end of the cage, that digit is the sum of the other two digits in the cage. So if it's this end, we don't know which end it is. It's up to us to figure it out. But if this was the end, say this could be 5, and then this would be 2, 3, and 2 plus 3 is 5. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So a 6 cage, since we can't repeat digits, the only option is 1, 2, 3. It's the 3 smallest digits I can put in there, and that already adds to 6. Now, we know this one's not the 3 because we need that hidden arrow. It's either going to be a 3 with a 1 plus 2 or a 3 here with a 1 plus 2. The rest of them aren't so easy. So we probably have to think about like how this resolves and how that probably affects this 8 cage. So let's think about this here. Let's say this was the 1, 2 pair. So if this was the 3 with the 1, 2 pair, just showing what I'm seeing in my head here, then that removes both 1 and 2 from these two cells. So the minimum I could put in them is 3, 4. And that actually does work. I would put the 4 here, the 3 here, and the 1 here. So that's viable. That's if this is 3, 1, 2. So what if it was the other way? I think the other way isn't nearly... I thought that might break it, but it doesn't. The other way would be a 3 here with a 1, 2 here. And so... Yeah, that definitely doesn't affect our 12 cage. Or sorry, our 8 cage. Oh, I said 12. Yeah, that's not... Okay, so the fact that this can be a 1, 2 pair annoys me. It does force this to be 3, 4 with a 1, so maybe that's an issue at some point. We do know that the 8 cage does have a 1 in it. That's just a property of adding to 8 and 3. If you omit the 1, it has to be 2 plus 3 plus 4 at minimum, and that's already 9. Now the 10 cages are pretty open. One thing that we do know, okay, so one thing that we do know is that the end is going to be exactly half of the sum. I don't know why I didn't think about that till now. But that means there's definitely a 4 at the end of the 8 cage, and there's a 5 at the end of this 10 cage, and a 5 at the end of this 10 cage. So what can we do about that? I mean, I'm seeing things like if this is 5, this would be a 1, 4 pair, and that would be a problem because that would put both 1 and 4 here. Does this force... This has to be 1, 3, 4 then, because it has a 1 in it and it has a 4 in it. So this is just 1, 3, 4, and that's not a 4. Okay. Now, with the 5 in it, it's going to be either 5, 1, 4. 5 is the sum with 1, 4, or 5 is the sum with 2, 3. Now, these cells can't be 1, 3, or 4 because of the... Look at the shape of this 1, 3, 4 and the 8. These two cells see the entirety of the cage. For example, if I tried to put a 1 here, notice how it removes 1 from the entire cage, and that's no good. So we can't put 1, 3, or 4 in these cells. So even naively, they're down to 2, 5, 6. Now we know that 5 is the biggest digit in the cage, so we definitely can't put a 6. That makes this a 2, 5 pair. We know the middle's not the 5. So that's the 2, that's the 5, that's the 3. That places 3 in this cage, that places 3 here. This is 1 and 4, placing the 2 and the 1. Places the 5 here, And now this is either 2, 3, which would go 2, 3 like this, or it's 1, 4, which would go 4, 1 like that. All right, now I assume we have to do Sudoku. This is a 4, 6 pair. This is a 5, 6 pair, and this can't be the 5. So that's 5. Sorry, that's 6, and that's 5, and that's 6. The 1 in this cage goes here, and this is our 4, giving us the 3, 2 sum. All right, now it's definitely Sudoku. Very clever puzzle. This is 5, 6. The 1 looks down, placing the 1 in here. And then this is 4, 5, 6. This can't be the, oh, sorry, not, yeah, sorry, the 6 looks down, placing the 6. That makes this 4 and 5. All right, that's a 4 and a 6 and a 5. These two digits are the 1, 6. That's 1 and 6. These two are 2, 3. That's 2, 3. 3 in the corner, celebrating. All right, now we just have a bunch of pairs here. This is 1, 5, like that. This pair is 2, 4. Not resolved yet. This pair is 4, 6. So that's the 4, that's the 6, giving us 2 and 4. And our last digit is the 2 and the 3. And we're done. We get 2 3s in the corner. Very nice. All right, very clever. I liked that. So I think the key deduction obviously was that the sum of the other two is going to have to be equal to half. The sum is equal to half of the cage total, which I think I kind of knew, but somehow it didn't immediately cause me to pencil that into the ends. But once I did it, then it forced the 8 cage, because the 8 cage couldn't have been the other option, 1, 2, 5, because you can't add to 5 using 1 and 2. Seems obvious in retrospect. And then that caused a nice geometric deduction against this 10 cage. Really liked that. All right, well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.